All right, we are back, and I'm back this week for another DoneJS contributor meeting. Last week I was in uh, Utah, sunny Utah, checking up on the Mormons. Went very well at Salt Lake City JavaScript. Got a really good reception there. And then yesterday I was in Milwaukee giving the same talk, which went fantastically well. So let me give my status. I did Salt Lake City meetup. I did Codes and Cans meetup. I did JS Jabber yesterday. I did the Milwaukee meetup. JS Jabber went okay. Everything else went really well. I've been working on the Bitballs application, making sure that's organized. I worked on Can Define, which I'll probably talk about a little bit at the end of this, because it's almost ready to probably be used by people. And I made some changes that improve performance quite a bit. And then this week, I'm going to LA tomorrow. I'm going to start working on a kind of a shortened version because I've got to I've got to kind of make like a 20 to 30 minute DoneJS presentation, which mine is more like an hour than what I normally give. And then I'm going to try to work through I've started the rough draft of the Bitballs guide. I want to complete that. And then at some point I want to do meetup planning. Plan kind of the DC and Boston meetups that I'm going to start going to. So that's it for me.
For the Can Define thing, did you figure out lists when there were a problem with lists or something?
There is a problem with lists, and there is no solution that I can think of. But I don't think it's a bad thing. I don't think there's a lot of... I think using can list is actually not so bad, because most of the time when you're using a list, you want to use the
push and unshift and all that.
Push and unshift, or you're using each, map, reduce, blah, 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 like the different methods. So the only outlier is length, but we can do a getter setter on length and make that work. So I think that lists aren't, I don't think that
you just can't get the nth item in a list.
Yeah, you'll have to go through an attr method to get or set that, like you do now. But I think I guess I don't think it's. If we're kind of talking about why are we removing the attr function? Why do we want to remove it so bad? It's because it looks gross and it makes people think that they're not writing JavaScript. You're not going to see an attr very often with an array. Your arrays will look like arrays, and I think as things like symbols land, then iterators and things like that. You have the for of iterator. We can make that work. So I think we can. I think until proxies land, I think we're okay having lists. Kind of still the old .attr way.
Does define property work? Does it only work with the dot syntax? Does it work if you do square brackets just on regular objects?
Yes. Yeah. If someone does a square property set, it will still hit getter.
Okay.
The other thing that we're losing, there's two things that are like kind of potential weaknesses, differences with the new define, which would be there's no sense of really adding properties. Currently you could know when properties are added or removed to an object. It's not used very often, but you could think of all properties are initialized to undefined with can define, and you cannot use the delete operator with it. You should just set all properties to undefined if you want them to kind of go away. But there's only set events that get produced. Oh, so there's three things. There's no changes. I'm getting rid of all of that bubbling stuff because it was bad anyways. So you can't listen to changes. And then there's one other thing, and now I've forgotten it. So we'll stay with those two things for now as potential weaknesses. So cool. That's my status. Who wants to go next?
I can go. Well, I'm here anyways. Last week finished up doing getting tests run in the Windows CI, which is now doing. I'd done the DoneJS release this morning. Actually, I didn't tweet it out. Maybe I should tweet it out. I was waiting for the test to pass in CI, which they did. Which is good. So yeah, DoneJS 0.7.0 is out now.
All right.
Yeah, the still.js release 0.14 yesterday was the thing that was most blocking that.
So promote it. What's it got?
What's it got? Yeah, that's a good question. I guess the biggest thing, most of it is steel changes, right? I'm not sure if there's really much outside of steel. Biggest thing is steel does no longer fetch all of your package JSONs up front. It just does them as it needs them. That's the biggest change.
I don't know. I think the plugin generator is pretty huge.
Oh, the plugin generator. So, yeah, sorry, I'd forgotten about that as well. Yes, yeah, generator to create plugins, components, that kind of thing. I should have been more prepared for this exact question.
Kevin, is there something else that you got in?
Not quite. Pieces of it.
Yeah, it's not quite in. I'll do a forum post. That's a good idea. I'll do a forum post announcing 0.7. Make sure I have everything that's actually in there.
Cool.
I'm working on James found a can wait bug yesterday. It fixed that this morning. And you had brought up, Justin, the fact that XHR was not being done right, that there was a possibility of onload being called multiple times. And that actually is happening. So refactoring that.
So we were both right.
What's that?
We were both right when we were talking about that.
Yeah, it was. So I guess the problem, the reason. Well, I don't know the reason why I did the wait, but the problem is that can wait. It has to do a couple of things. It has to wait on stuff, but it also has to run tasks. So I've kind of refactored it now to where there's now a new task object. Yeah, this is the code that's a problem. But what was the problem was that it has to wait on stuff, but it also has to run these tasks. And the code to do that was kind of tangled together. So what you need to do in XHR is you need to say, hey, let's wait on something. But that's not necessarily the same thing as. But you can run multiple tasks. You could run an onload event task or an on-air task. So there's multiple tasks. So I'm working on refactoring that so that you can do that. You can say, hey, I need to wait, but not say not provide a callback that you're going to wait on necessarily. Then when you're actually done, you can say that you're done.
Yeah, I think that.
So this is going to go. What you're just looking at is going to go away. I do need to do on ready state change for IE8 because IE8 does not support onload. But in browsers that support onload, I'll just listen for onload and on air. And I will not call onload in on ready state change.
So this is part of this will be all kind of cleaned up, I think, right? As you and Brian start working on the can wait article, the APIs. Yeah, I think naming is going to be very important for this. What does a task mean? What does an override?
I think task is the right name. Yeah, all that definitely. It's definitely true. I think task is right because that's what's used in the literature. A task is a callback essentially, like a callback for a set timeout or for a script itself is a task.
Yeah.
But yeah, there's some other names there. Yeah, I don't know if request is the best name. Could rename that to zone.
I'm all right with that. We can use terminologies other have spread.
Right. Yeah, so I think next is probably do more of this can SSR than can wait stuff.
Okay, so yeah, for next week, what's the plan? Is the moving to
So
can't wait.
there's actually a CanSSR milestone that has. So Brian's working on CanSSR and can wait articles. There's a CanSSR milestone which has refactoring the CanSSR APIs and can wait APIs.
Yeah, I think that'll be really important for you know, working closely with Bitball's team to make sure that server-side rendering works really nice in that app and does everything it needs because it has the cookies and everything like that.
Yeah.
Cool. Awesome. All right, David, you want to go next?
Yeah. I had it so well prepared, and now I forgot it all. Anyway.
The plugin generator.
I know. So last week I finished a plugin article. I got some feedback on that from Brian and Adam that I started going through this morning. So I'm going to finish that since we published DoneJS 0.7. I'm going to publish that article once I went through that as well. So we have that article, and then I'll also merge in the guide, which is pretty much the same thing as the article. So we'll have with DoneJS 0.7 a way to generate plugins that you can share and publish to npm. And then it works pretty nice. And then this week last week I also did a CanJS release, and this week I started working on the generator. We have to make a generator to generate new generators. So I started on that and write up some of the steps that are necessary to write your own DoneJS generator. Took me a little bit to figure out what I'm gonna make, but I think I'm gonna make a generator that adds JS hint to your DoneJS project. So you do DoneJS add JS hint and adds the configuration file and updates the tests that it runs JS hint against it, because we don't have that included at the moment. So that was a good example. And then I'm going to write all of that up into a guide as well, turn it into an article, not the other way around this time, because I think it's better. Hopefully, I don't know if we're going to be able to do it next week, but at the latest the week after, at the beginning, to release that stuff.
What are you going to use as your example generator?
The JS hint.
Oh, JS hint, not what's it called? Raspberry Pi blinking?
Well, so that's hard, but we can. Okay.
Maybe if anybody's played with Raspberry Pi here, or maybe we can reach out to Batovi. Maybe there's someone who has played with it enough who could make it relatively easily for you, who knows the setup.
I don't have one. I used to have one, but it's an art project. So it's kind of gone.
Get them on Amazon.
I'm not.
Yeah, not in Canada.
Oh,
It's
really?
really interesting. They say like, hey, look, a $25 computer, but here it costs about $60 to get it, $60 Canadian. Anyway, so I'm gonna go with the JS hint, but yeah, we should maybe do. So there's a couple of generators that I think should happen. I talked to Matthew for 0.8. We're gonna pull out the deploy stuff into their own modules. So you do DoneJS add Firebase. Because DoneJS, like even Heroku, we don't have to do through Travis CI. We can also create a generator where you just say DoneJS add Heroku, and it does Heroku deploy for you. So we want to fix that deploy. I would like to see an Electron generator, additionally to NW, and then we can also do the Raspberry Pi one. So once all the infrastructure is good to go, we should be able to add new generators pretty quick.
Yeah, there's another one too, but yeah, that'll be very cool. I think being able to allow people to create plugins and generators and kind of contribute back their ideas will go a long way to spreading DoneJS's goodness. So very excited about that. So when is the article coming out?
Today.
Published. Cool.
Just some last tweaks, and then we'll merge the guide and publish the plugin.
Awesome. Great. Cool. Kevin?
Yeah, so I finished the work on, or the code, I guess, for Steel Clone. I put in the pull request for that yesterday afternoon.
So what does Steel Clone do? What is
So
its
I think,
goal?
yeah, I showed this off a little bit last week. I can show it again. Um, so Steel Clone makes it so you can clone Steel's loader, and you can pass in some modules to override any of your real source code. So this is the Bitballs app. This is the source on the left and my test over here on the right. And the source is using this tournament model. And for my tests, I don't want to use the real tournament model. So what I'm doing is creating a clone of the loader and passing in, this is the module name for that tournament model, the same thing we've got over here. And it's just going to return this promise that returns back some fake data. And then I can import my source code and test against that. So in my testing, I'll be testing against this view model that has this basically injected version of the tournament model. So that is my primary use case for Steel Clone. But
Would you say your primary use case would be called dependency injection?
Yeah, right.
Awesome. Yeah, I mean that's gonna be. I think that'll be really. I think doing dependency with the module loader, injection with the module loader, I think is really where it should be done. There's a really good place for it. So I'm excited for this to kind of be like, hey, Angular folks, what everybody praises in Angular, we will have, I think, a very strong answer for.
Yeah, it's really nice. You can do it with any of the module formats. This is ES6, or actually this is CommonJS, but you can do ES6, you can do Seal, you can do AMD, whatever. So inject any type of modules that you want. So yeah, the next thing that I'll be working on is the dependency injection article. I just started working on outline for that, so I'll be working on that, and then hopefully a rough draft in the next few days.
Awesome. Very excited for that. Cool. Does any of the Bitballs folks want to give a quick status update where we are with that? Or I can.
I've just been working on CanSSR, trying to add cookie support to it so that we can use it in Bitballs. And I found that can wait bug that Matthew talked about. Yeah, so I'm just working on adding that. One of the tests is breaking right now, the asset helper for CanSSR, not because of the changes Matthew made for CanWait, but because of stuff I'm working on right now. So I'm trying to figure out why that's breaking.
Yeah, so I meant more on a high level where we are. So we're almost completing all of the DoneJS-y kind of setup things. Server-side rendering is probably, I think, at this point, the last one that we're completing because we had to make sessions work. And then we're going to, now we're moving on to actually just making the app like a reasonable app to use. And hopefully next week we will be cleaning up all of the code. And after that, the guide should land. I'm actually going to probably put up the guide earlier than that, just in rough draft form, because I think once we have the server-side rendering part working and we have the deploy, even if the app isn't super pretty to look at, the code yet, and fully tested, I think there's still a lot of advantage there for people. So, and even if my writing isn't good, I think there's still a lot of benefits. So I'll probably have the guide up the second server-side, the guide rough draft, the second server-side rendering lands. So people can check that out. Very cool. Let me go through, let's see here. Any other updates? So Sheriff, he was working on can define before I kind of like just went in there and threw away all of the code that he was so awesome for writing, because I was just like, I had a flight, I wanted to play with something, and I knew that I could make the way we were trying it, him and I were trying it together much faster. I had an idea about it. And he's also working on translating the CanJS 2.3 article to French. And then he's going to keep working on can define with me and finish the article translation, hopefully publish that. He's going to publish that on his own blog, which I said is totally fine. And then the only other person is Adam. And he said that this week he's basically to start the process of moving out EJS and Mustache into their own plugins, and then making it so right now everything kind of depends on CanUtil, and then CanUtil depends on jQuery and all these other things. Instead, we're going to make a version of CanUtil that doesn't depend on jQuery, and instead every module is kind of going to load just the util things that they need. This will be so that, and we're going to change CanJS for 3.0 to use CommonJS. This is so that if you are using on Node and want, for some reason, which I think there might be good reasons, to load the template engines, or you want observables in Node or computes, that those things just work. Things without, or you want like the can construct, things that don't need a browser, you should be able to use without, having to load jQuery and load a DOM. So he's going to be working on that. And finally, I want to talk about what I did with CanDefine. Kind of went over this a little bit already, but so really, so CanDefine, let me show the test, because that's kind of fun to look at, is comparing the just taking a look at what the code looks like with the new. Let me try to find. Oh, here's kind of one crazy thing that I did, but I'll come back to that. It's a nice small example here that has a lot of attrs removed. Okay, here's kind of a smaller one. So you'll notice it's not calling .attr, your getters. And when you set and read properties, you don't have to use .attr. You can just, use the normal dot operator, and you can set to objects and things like that. And it will hit the getter if there's as the last set value if there's a getter, things like that. So this is probably a good example just to look at. There's two ways to use the define plugin right now. And by the way, if there's comments about this API, now's a good time to bring them up before we get too deep. If you want to create your own constructor function, you can do that, and then you can use just normal define to say, hey, on the prototype or on any object, really, I want to create these getters setters. And it will, if you're doing, you set the property and you do a define object, or you can do the type. So you could say first is a string, but if you do star, that just means really there is no type. It's the any type. We could have any here if we wanted to be very much like, I think, C#, or I forgot what language where I've seen this before. But I have star here. And you could write your getters, which is normal dot operators. But anyways, there's one form of define, but if you want to create a, where did that example go? If you want a normal can map like constructor that you can pass in an object of key value pairs that will get set on that instance, there's a define constructor where essentially you're passing the same things to go on the prototype, but you're not defining. I mean, it will create a constructor function for you and add these things to the prototype. So yeah, all of the, right at this point, oh, there's no serialize. That was the other thing that I forgot. There is no serialize right now, but we can create a serialize function. But I'm just working on the normal getter setter stuff. So yeah, you just define, just like you used to, get, set, type, value, and this all works. Let's kind of, one thing I did want to show off is I made it so you can nest types. So this is something that Josh Dean kind of added to the old the current define plugin, but it was based on value, which actually doesn't make sense, and I kind of never put enough thought into that pull request to realize it. Really, you should be able, the defining of nested type should happen on the type object. So what I can say here is, okay, I have this examples property, and its type, well, I'm going to define a type for that nested property and say, hey, examples, its type of, it's an object, which is kind of weird that's called examples, even though it's an object. It's going to have a 1 property, and I can define its default value, and it's got a 2 property, and I can define the type of the 2 property. It's got a default value of object. And that internally, too, it has another deep property. The 2, basically the 2 property has a deep property and its value. So it's kind of weird, but this is how you could describe, like, maybe a better name is, like, let's say I had this was a user, and then it had a name, and a name had a first and last property. You could do that like this. So here's my name. It's going to have a first, which might be a string, and a last, which might be a string. You can declare this kind of stuff now, so you don't have to create like a separate separate name constructor. You could just do this. Give you guys a second to think. Any thoughts?
No, really, it's pretty cool.
Okay, cool.
So previously, before we had the nesting, in order to have a kind of a nested but defined map, we would use uppercase type?
Well, you could use uppercase type, yeah.
Or would we use uppercase value?
No, to do nesting?
Not nesting. I'm saying,
no, you use uppercase type.
Let's say I had that.
Yeah, so the old way, and this still works, is I could say, hey, there's a name type define constructor, and you would just take this here, and you would say that, yeah, you'd say capital T type.
Okay.
So personally, I would actually probably still do it this way, unless this is nice for when you have just kind of like, I would say, micro types that you really don't want to be messing around with. But I think this is also going to be really important. This syntax, I think, is actually critically important for the success of the define plugin, because the good thing about can map currently is that you pass it your object, and whatever properties are inside of that object, they're going to be made observable, right? So if I didn't have this and I had a name object and someone passed it this thing, something like or let's say this, we could actually do something about it. Let's say someone went something like nested. We could probably even do something about this, but it would be weird. Nested name, right? And they did something like first a nest m, or then these things would not become observable without defining them essentially ahead of time. So you need that type first string. So you need this. So I'm glad this kind of expresses itself, and hopefully this is something that people can understand and follow.
Did you say earlier that it doesn't work for can lists?
I guess it depends on what you mean by it. There is no. You still use can list with this, but this doesn't work. Like, you can't define a custom list. Although actually you might be able to use this to define, if you wanted to define like expando properties on a list, you could actually probably use this, and those would be observable. But to access the properties and the items in a list, you would still need to, you just use normal can list and go through the attr method if you're going to do that.
If you had like a list of lists, though, could you nest the map types for the objects in those?
List of lists. So lists, like, yeah. So you would have to do, if you wanted, like examples was, you can't nest that, but if you could just do, you know, my list here as a type if examples. I don't know if that's what you're talking about, but if you had an examples list type, you can do this, and then it'll create that list type here. And then you'd want to define examples to, you'd want to define examples to specify its static map property to actually be like a different can constructor. So there's probably some, but no, you can't do like lowercase type and somehow inline define a custom can map, right? The way to do that would be instead just have your type, and if you, or can list, I mean, you could just do something like this if you really wanted to make it inline. Right? If there was like an example type, do that. So at the point you're needing lists, you would probably want to go outside and not use this kind of nesting ability, because it really wouldn't work well, or wouldn't look good for sure. Do this. All right, so let me go back here. Something else that I wanted to talk about. Oh, just real quick, how it's built. So this is built, I mean, I guess Matthew would be super familiar with, or anybody who's looked at Can Connect would be very familiar with how this is built. It's just a bunch of behaviors that wrap each other successively as, you know, for a property definition. So, okay, this property definition has value, and then also is inheriting a set and a type. And essentially what we're doing is we're building the getter and setter functions on each property, and we're kind of, you know, starting with a basic getter setter, and then as things like type or setters or getters are called or are defined on that property, we kind of wrap that inner function with an outer function to eventually build up all of the behavior that we need. But what it does, because we're doing it that way, it makes the base, this kind of form where you're really not adding any other behaviors, super, super fast. Like 3 times faster than current can maps to initialize. I'm not how much faster to change, but I'm going to guess it's much faster. I haven't tested that yet.
Why is that?
Why is it what?
Why is it just because that particular behavior is not doing very much, so you don't have to check a bunch of stuff?
Yeah. So
like
think about like if you're looking at like how can define work. Like if you're talking about can map, and if you've added the define plugin, and you set or you create a property, well, when you create a new instance of can map, it's doing a lot of the same things as when you set a property. So updating should probably be 3 times as fast. My guess would be just like initialization is 3 times as fast. So there's a lot of performance benefits because we're basically removing a lot of code. So if we could take a look at it, let's just talk about like just to read a value, not even set a value, to read a value, what the current map has to go through. First, it has to check if there's a dot operator here. we don't have to do that anymore because you're using, you can't do that. You can only read one key value, right? So, huh?
One at a time.
Yeah, one at a time. So no check here. So, okay, we skip that. Then, well, we know if it's a computed property or not because we know if there's a getter defined on it. So if there's not a getter defined, we write out a function that never even has to do this kind of check, right? All we do is call can_observe, and we then, again here, old can map, it would have to say, okay, well, now is it a computed property? If it is, read it. Otherwise, read the value in data. We don't have to do any of that when you read a value now. All you do when you're reading a plain value that's not inside of a observable, which is like most properties generally, we have this. This is all the code that you have to do. So this is the function that we essentially write out to read. Now, the problem with setting is even worse if you think about it. So the map, like if you have if you're trying to set, you got to do that same key thing. Then you might have to run a type converter. If there is a type converter, then now this is where actually _set is called, but the define plugin actually overwrites $_set. And that's going to create an error callback, check if there is a getter or setter in the definition, which that's going to take some time. Then actually, presumably there's not a getter setter for the simple case, so it's going to skip that and then call to the old set, which is then going to get, the type converter, which I already talked about, is removed. Then it's going to get to the old set. And then again, this is going to check, is this a computed property or not? Then we're going to figure out how to, what type of event we have to trigger off. Then we have to say, oh, is bubbling turned on? Then are we going to, if it's not a computed property, then we're going to trigger a change, maybe possibly tear down bubbling, where this, for the simple set, is two things. There's two functions that get wrapped. There's this one that makes sure the events run, so it gets its new value. It's going to get the current value, which is just kind of a read that's not observable. Check if it's different. If it is different, it's going to do the set, which again, all that just looks like this now, calling a function, and then it's going to trigger an event. So this inner function, this, and this read, without non-observable read, are all it's doing. So the amount of code and branching is just dramatically reduced because we're essentially building just the code that needs to run depending on the type definition. So the trade-off here, though, really is going to be that building these constructors, like actually defining your types, is going to take a little bit longer. But I think because one project might have 50 types, it would be a huge project. I don't know how many. Well, not huge. I would say like 100 types would be big, but that's nothing compared to the amount of every single instance of all of those types, them all loading and setting their values. So it's just huge, epic win basically. And the cool thing is, I could even be a little bit faster because even for the base, when you have that star, I'm doing a little bit of just short-circuiting the building, but I could actually just inline the functions here if we really wanted crazy performance, and not even kind of be building those functions. I would just inline a version of them so it doesn't have to make these internal function calls to work. I could, I don't even have to. Well, get really couldn't be any faster, but the set I could just inline a function here. So it's cool. And again, the logic is basically it's just checking the definition, and based upon that, it's making a getters and setters really. And you can see it like, let me just show an example. Really what it's doing, a lot of the work is on overriding the setter based upon whether you have a getter or setter, or you just have a setter, or you don't have a getter or setter. It's kind of just taking the dummy setter and overriding it with any additional behavior. This one actually overrides it twice. And then if you have a type, it also overwrites the setter. And then eventually you get down to where you've kind of built out your final getters and setters, and you define them. So, and then the nice thing is I just have this object then that has kind of four. Well, if you're setting computed data on the object, well, it looks like this. If you're setting normal data, it looks like this. If you're trying to generate a function that's going to trigger events, then it looks like this. And the fancy setter, when you have a setter, looks like this, and it takes the old setter and overwrites it. And just there's a bunch of helper functions that kind of take a lot of times the old behavior, part of the type definition, and generate new functions that call kind of the old setter. The reason why I want to talk about this is because the reason why I said Matthew would recognize this pattern is this is very much like how System.js works, and this is also kind of how Can Connect works. Is this pattern of you take your base functionality and maybe some other options, and you overwrite it with kind of the new function that adds some new behavior.
Wonder what's the performance though when you do like these deeply wrapped, you get these like really deeply wrapped functions. I wonder.
How does it compare to the?
How does it compare to like
current can map with the define plugin?
No, just more generally speaking, how does like wrapping a function 10 times compare to prototype methods, for example?
Well, I think what it comes, I mean, really what you're talking, like, if you're going to compare the performance of can maps and using the define plugin to this, the number of function calls is when you have something with like a getter, a setter, a type, and all of those, like if you defined every single behavior on where are all the behaviors, or like almost all of the behaviors on a definition, a property definition, the total number of function calls is going to be the same. Or actually it'll still be less for can define, because it's not having to go through the underscore set and the underscore get methods. The difference between, it's not a difference of performance, but really there's going to be a difference of memory. Because what you think about is like, you're talking about we're overwriting another function.
Well, I guess I'm thinking more in terms of like steal. Like we wrap normalize, I don't know how many times, probably 15 times or something like that. You know, each time it's calling the parent function, so you wind up call normalize and you actually call.
Yeah, but think about it. You're calling functions in your scope, right? Which this is doing too. So where's the example? Where's like a small one? So type here. Here's the old setter. It's calling that after it does the type conversion. Now, if this were the old, the on the prototype, well, it might be calling this dot like next stage of set, just like the older one does. But it's still a function call, and the only cost difference is the looking up on the prototype or the object, the dot operator, versus looking up in the closure.
Right.
And performance differences of that, I actually did look into, and I don't remember, and I bet it's totally negligible.
Because you still have scope within a prototype method anyways.
But that's the biggest issue is going to be more memory, right? These are going to definitely take up more memory than the like if you had a bunch of define, like if you extended can map a million times, there wasn't very much we were having to build or do every time CanMap was extended, because all of the logic was really added to CanMap's, the base prototype. And you just had your definitions, and it would look up your definitions while the setter was happening. Instead, we're creating a new function for every single definition. Every behavior of every single definition, we're pretty much creating a new function. Now, JavaScript functions are pretty light. The total number of definitions, my guess, is not gigantic. But this is, I'm of the belief that the slight additional amount of memory is very much worth the cost of 3 times better map initialization and changing, because I just don't, the ratios there of how many type definitions are created versus how many instances are created, even in startup time, is substantial. How many maps are created in a project versus how many maps are defined.
So from a DoneJS perspective, how should we get this in DoneJS?
Well, I think the first thing we need to do is pick a example app to start using this.
Bitballs, for example?
I was thinking about Bitballs. I don't know if that's, I kind of want to get it out, and I don't want to be like, hey, here's an example app that looks nothing like nothing like everything else. I kind of want to, I don't want to do that. I want that. I think maybe we look to this for one of the other example apps, or maybe like what Chris might be going and doing is like Searcher and to do MVC. Maybe this is a good maybe this is a good example for Searcher or and to do MVC example apps. So, something small where we can use it as a proof of concept.
Yeah. So you can create a type and use that as your CanConnect map, right?
Use a type and create it. Yes. Well,
it won't have a list though.
So this is because this is going to be the problem. Is like, well, let's say what I really want to do is use this for components, right? I would really like to say in CanJS 3.0, this is, yeah, these are your default view models. If you just put a default, if you make a can component and you put in that object. Right, if you just put in an object here, we're going to there is kind of one problem to this is like when you have functions, but we're gonna have to figure this out so that because currently you would, if we want to be backwards compatible, what we would have to do is like say, well, everything in the define here, this is the actual prototype definition, and we're going to just kind of like see, hey, is there a define? If there is, we're going to move everything over. Because previously, people would be able to write something like name, hello or something, or message, and this was a default value on the prototype. But now we're saying that this should be the type. Really, what we'd want that to be the type. So I don't know the best way of migrating. I mean, we definitely should make it so that this works. If you have just a normal define constructor. We definitely need to make this work. But I mean, one problem is a lot of CanJS is looking for things as is a can map. Right? Very much there's a lot of potential behaviors that are like, hey, if this isn't a can map, then I'm going to do something else. We got to make sure that these are all going to work for 3.0. Observability should work. I haven't tried it yet. Like if you're putting these things in Stash, it should work. But yeah, I haven't verified that. So there's still a lot of work to be done before this is totally ready. But I think our roadmap is we should and do the same thing I did for CanJS 2.0 is make a to-do MVC or small app that kind of looks right and use the new technology, kind of a pseudocode, and then make it work. And which I want to be backwards compatible as much as we can. It'd be nice. I don't know what to do though about like the old way of creating definitions. I mean, maybe we just say, hey.
That matters. I mean, I don't know. I almost never do that.
Yeah, but I think there's probably a lot of people.
I think we even discourage it, didn't we? I mean, it feels like we like, I don't do that.
Yeah, but I guarantee there's people doing it. I mean, we can give them what I think we could do is just give them a warning to say that. One thing that this needs to do too, which I forgot, is like if you have
could we make it backwards compatible by if you're not using can define, that it works the old way? If you're using can define, it works.
Like you've loaded can define, you mean?
Yeah.
No, you can't.
Why?
Because I wish you could, but it's very. I guess maybe you might be able to. It's weird when you have modules that work that way. It's like, well, okay. I guess you can as long as you're registering can define on can itself, and then you could say, well, yeah, I guess you can do it. It's just a little weird because you're kind of breaking module boundaries there that way. The other thing that needs to be figured out is, so like I said, the default value is right now it's the type. But people I think are going to want to be able to create, if they're going to use define constructor, they're going to want to be able to create their methods. The problem is right now I'm assuming that this is a type definition and not a function. So I'm not sure what the right API here should be. We could make it so that it's only string types are allowed here. But I don't really like that. But maybe that's what we do. Is that if it's a function, it's not a type, but then it just gets weird because you can allow functions in the normal type.
What do you mean by a type? Why is the string a type? What do you mean by that? Oh, I see. Yeah.
I am going to make it so people can more easily do. I'm just giving up and saying that if you can add your own types now, right? You can just do this in some module and have all of your.
Why do you say giving up?
Because the whole idea is that you could always you don't have to add to type. The whole idea is even now you could just have your module that exports a bunch of types for you. And you could just have your own myType function. And then current can map, you should just be able to do like, well, here's my types.mytype, and just do it that way. But everybody wants to use a string, which there's no reason to use a string. Or sorry, not there. It'd be here. Right? You can always do this. Always easily create your own type functions and pass them around. Right? I mean, we could force people to do something like type define.types.string. That feels gross, and I think that's what it is for people. It's people just want to feel like this is almost like, compiler type definition type logic. So that's why they want the inline. That's why they want to be able to do that, even though I don't want them to think that way. I just think it's just like too natural. So I'm giving up. And allowing people to do it this way, and we can document it.
What if we just had a methods property that was where you defined all the methods inside of there, like we had defined previously?
Yeah, I don't. I'd rather have just the define property and keep it consistent then. You know what I mean?
Yeah, I guess that makes sense.
Yeah, I'd rather have it so that it's all. I'd much rather have it so it's which I think is mostly reasonable. That I think it's reasonable because on your prototype you should never have anything other than functions or object definitions. Right? You shouldn't be. It'd be very weird to have something like foo new thing on a prototype. Right? You just generally don't and should not do this. I can't really think of a case in application where someone has done something like this correctly. So part of me feels like the compromise that I might is just you can have type definitions. So you can have strings for type definitions or objects for type definitions, but you can't have function type definitions first level. If you have functions, those are actually functions. It's the rules are complex, but I don't know. I just think it's the most natural looking. Right?
Yeah, I think you absolutely have to be able to have functions.
Well, the alternative is we could say is what's the ES6 class syntax? Hold on 1 second.
No, I'm saying I agree with you. You need to be able to have methods.
Oh, I know you need to be able to have methods. It's like, what does it look like? So here's an ES6 constructor, and you can have your other method, you know.
Yeah, you can't put objects on that, I'm pretty sure.
So this is one other consideration, is people I think really want to use classes, but classes don't give us an instantiation hook or definition hook, which would be really nice. Is that if any if all of the ES6 spec people are watching this at home, if we can get a callback to know when like Polygon or some other class would be extended, that would be huge for us. But right now, that's why I wrote it this way, so that you can do define Polygon, and then you would do with number 8 number. You could do this after you defined all your functions. I do not like this, but it makes it possible. I don't have any other ideas though. But I think it is important for 3.0 to be able to work with the class constructor. I just don't know how to. I don't know how to make it work elegantly. I don't know if any of you have ideas. So, anyways, I guess this is where my head's at. This is what I'm thinking about. If you have a eureka moment in the shower tomorrow, please let me know. Be like, this is totally how this should look. I'd appreciate that. Cool.
Cool.
Thanks, everybody. I think that's it for our meeting, and I will see you all next week.
Thanks, everyone.
Yep.
See ya.